we have the C1000 and the M2000 platforms. And the C1000 is what we would call a lighter version. So this controller has 4 inputs and 5 outputs. Out of the 5 outputs, 4 of them are digital, 1 of them is analog. And this controller does not have an internal schedule to it. So if we want any kind of scheduling or anything like that, we need either a dry contact, so some kind of external timer device, or we can send it a schedule from a network controller. And then we have the M2000 controller. So this is what we would call the full version, if you will. So this controller has more inputs and more outputs. So this one has 9 inputs, 8 outputs. 5 of those outputs are digital and 3 of them are analog. Each output has its own handoff auto switch, so we are able to override the outputs. This device also has a built-in time clock with scheduling. So differently from the C1000, where it needs an external device for scheduling, the M2000 is fully able to follow its own schedule with a yearly calendar for holidays as well. It is important to note that both of these can work standalone or networked. So you do not have to have these in a large network system. If you're just looking for a simple standalone controller, both of these will do. Now, in terms of the part numbers, we actually have 4 rooftop controller part numbers. So we have what we call the RTU and the RTU-S devices. So as you can see on the 2 top lines, we have the C1000 RTU and the M2000 RTU. Well, as we see in the PowerPoint slide, both of these are for zoning systems. So what that means is that these controllers need follower controllers on its subnet bus to command it either in heating mode or in cooling mode. Today, we are not going to look at those too closely. Today, we're going to focus on the second row, which is the C1000 RTUS and the M2000 RTUS, which is for single zone units, where all we need is just a simple wall sensor to command the unit in either heating mode or cooling mode or simple ventilation mode. So in terms of the C1000, just looking at the inputs, well, since it's the lighter version of the controller, we have inputs for 3 temperatures, the supply and return duct temperatures, as well as the outside air temperature. And with the digital input, which is basically a dry contact, we can either use it for occupancy or for the supply fan status. On the outputs, this controller has 5 outputs. So 1 output is for the supply fan. We've got 2 dedicated outputs for cooling stages, and we have 2 dedicated outputs for heating stages as well. Now you'll see under the cooling outputs that if we add a DMUX-4J, we are able to have up to 3 or 4 stages of cooling. So this particular part number is from the manufacturer ACI. So if you look them up and you look up what a DMUX-4J is, then you can see that interface, which allows us to have 3 or 4 stages of cooling. Also, if ever we want a modulating cooling signal, we are able to achieve that using another interface from that same company, ACI, which is called the PTA2. And so what this converter does is that it allows us to convert one of our digital outputs into an analog output. And we can configure it either for 0 to 10 or 2 to 10 volts. On the heating side, Well, this controller has a analog output already embedded on it. So if we need modulating heat, we don't need any other interfaces. It is built into the controller. And so here we're going to see the actual wiring diagram of the C1000. So as we can see at the bottom, terminals 1 and 2, that's just for the power supply. Just above it, we have output 1 for the fan. Above that, we've got our 2 outputs for cooling, Y1, Y2. And then on output 4 and 5, we have our 2 heating outputs. And on terminals 13 to 17, there we can see the different inputs for the different temperatures and the dry contact inputs. And finally, terminals 18 and 19, those are the communication terminals. So when you want to daisy chain multiple of these all together, those are the 2 terminals where you are going to land your wires. Now on the M2000 side, so like I mentioned before, this has all the same capabilities, but it can do even more than the C1000 because we have more inputs and outputs. So we have the same supply, return, and outside air temperature sensors. We can also connect a mixed air sensor. We also have a dedicated inputs for a analog sensor. So if we just want to use like a 10K type 3 sensor with a potentiometer, whether it comes from a third party or if you get ours, it doesn't matter. We can connect it straight into the M2000. So there's a dedicated space, temperature, and set point inputs on this M2000. Additionally, to this controller, we also have a dry filter contact as well. So if we want to monitor the filter in the unit and see if it's clean or dirty, it's simply using a differential pressure switch, we can achieve that. We are able to connect a CO2 transmitter. So whether it's a duct transmitter or a space transmitter, so for CO2 levels, there's a dedicated input for the static pressure as well. So if we want to control any kind of bypass damper or variable frequency drive. However, in this case, we're not going to use that too much since today we're talking about constant volume systems. And there's a dedicated input which can be used for a relative humidity transmitter. And so with this, we can essentially enable a dehumidification sequence. So on the outputs, well, we have a bit more choice because instead of the 5 outputs with the C1000, now we have 8 outputs on the M2000. So we have a dedicated output for the fan. We've got 2 outputs for cooling. We have the same setup in that we can activate up to 3 or 4 stages of cooling using that demux converter from ACI, or if we want a analog cooling signal, we just use the PTA2, so that remains true for the M2000 as well. We have a dedicated output for the outside air damper. If we want to do a economizer sequence or indoor air quality for a DCV, demand controlled ventilation, so we are able to do that with this M2000 controller. On the heating outputs, it's very similar to the C1000, except for we have 1 additional output. So instead of 2, we actually have 3 outputs. We have a dedicated analog output for a bypass damper or variable frequency drive. And we are able to use actually one of the heating outputs. We can reconvert it if we want for either exhaust fan control, which would be based on occupancy, or we can control a little power exhaust fan if we have one in the unit, which will activate based on the outside air damper position. So looking at all these inputs and outputs on the M2000, here we can see it right there. So on the right-hand side, we have all the inputs. So starting from the bottom, we have the outside air, return, and supply air temperatures. On input 4, as you'll see, it's a multi-purpose input. So we have to choose which function is it going to do. So we can't do all of them all at the same time. So the first option is a mixed air sensor. We can use that input for the dry contact for a clogged filter. If ever we need some kind of override switch to be able to push the unit into override mode so that it becomes occupied simply with a switch, we can do so right there in input 4. And the last one is called auxiliary temperature input. And that's simply for monitoring purposes. In case you just want to monitor a fourth temperature, which isn't necessarily related with the actual rooftop operation, but we just want to monitor it. I've seen it used for some space which might not have its own sensor, or maybe in a restaurant where they wanted the temperature of the freezer to be monitored and so on. So here's just a general input which can be used for any kind of temperature sensor which you would want to monitor. Input 6 and 7, and those are for the analog wall sensor. So if we just have a 10K type 3 sensor with a potentiometer, we're able to connect it there. However, in input 7, and that is also the one if we want a zone humidity sensor, and that has to be 0 to 5 volts DC. So depending on what you're achieving, on what you're looking to achieve, we will use input 7 either for the humidity or for the space temperature. However, as I'm going to show you later on, we typically don't use inputs. We don't typically use the inputs 5 and 6 for a space temperature because in that case we have to use a analog wall sensor, and we would much rather use our digital wall sensors, which can give us more options as well. And I'm going to show you how to connect it. So it's not going to be on inputs 5 and 6, but it's going to be on somewhere else on the controller. On input 7, we have the dry contact for proof of fan. So we need fan status before our unit is permitted to either heat or cool. Input 8 is the CO2, and input 9 is the static pressure. And then on the left-hand side, we have all the different outputs. So we can see our digital outputs 1 to 5. It's basically our fan, our 2 cooling stages, and our 2 heating stages. Now, and you'll also notice that digital output 5 can also be used for the exhaust fan or the power exhaust, or in case we wanted to just control like a little baseboard or a zone valve, which once again is not tied to the actual unit itself, but sometimes we just need an extra output for peripheral heat. So we could use output 5 for that. And then on the 3 analog outputs, we've got our modulating heating signal on analog output 1, the economizer for the fresh air damper on analog output 2, and the bypass or variable frequency drive output on the analog output 3. Now, once again, we're not going to cover that too much in detail today because we're going to focus on the constant volume applications. So in terms of the wall modules, the digital wall sensors, which we offer at ProLon, we have 3 different models. So we have on the right-hand side, we have the entry-level model, which is the T200. And as you can see, it's just an adjustment knob. We do put a temperature scale on the label. We also have another label where we don't see the temperature scale, but we just see a plus minus sign on each side. So in that manner, people aren't controlling to a specific temperature, but they're simply indicating do they want it warmer or cooler. We have different coloring schemes available. So we can offer these wall sensors with either a white box or a black box. And then in terms of the label, here we have the one in the middle is a white label, and the T1000 and the T200, those ones have the gray label. So we can do any combination, whether it's a white box, gray label, white box, white label, black box, gray label, and so on. So any combination, we are able to offer that. With the T500, which is the middle range one, Now we get a digital display. We also get an adjustment knob. So we can't access any menus or make any changes, but we can still view the space temperature. And then with the T1000, this one has a digital display and a touchpad. So when we're changing the set point, it's very similar to how you operate an iPod. So it's just with a circular motion with your finger. You can push the set point up or down. Now, the T1000 has a certain menu structure. However, we have not included any menus right now for rooftop unit controllers. The menu structure is only designed for VAV controllers. So we're going to get into that next week. All right. So when we want to connect these digital wall sensors to the rooftop controllers, well, if it's a C1000 controller, we have two options. We can either use a network cable, so a Cat5 cable with RJ45 connections at each end. So all of our wall sensors have an RJ45 port on it, as well as the C1000. So you can simply click the cable at both ends, and then you'll see the wall sensor will power up and it'll start communicating back to the controller. Now, another method to connect the wall sensor is with a 4-conductor cable. Now, since the C1000 doesn't have 4 terminals dedicated for the wall sensor, we have a little adapter. It's called the T1000-Adapt. And all it does is it converts the 4 conductors into an RJ45 port. So just remember, if you're using a 4-conductor cable to connect one of the wall sensors to a C1000 RTUS, just remember that we will need that adapter right there. Now, when we get onto the M2000, it's a little bit different. Number one, we can't use that Cat5 cable. So in this case, we must go through the with a 4-conductor cable and simply follow the wiring diagram as we see here. We have all these wiring diagrams available on our website. So it's as simple as just connecting the 4 terminals on the wall sensor onto the 4 terminals as we see here on the M2000. Now, I'd just like to point out that all of these 3 wall sensors, so the T200, the T500, and the T1000, they are completely interchangeable in the sense that they all connect identically. So if ever you chose one and then you wanted to change paths and use a different wall sensor, but you've already installed one, no worries. They all connect exactly the same way. And on top of it, all of the terminals on the back of these wall sensors, they're all removable. So you don't even have to remove the wiring from the terminals, simply remove the terminals from the wall sensor and then just swap them, and then you're good to go. Okay, all right. So we've covered a lot of the hardware aspect. And just one last thing before I jump onto the software is that when we want to communicate with our controller, and we want to make sure that the controller communicates with its wall sensor, it's very important that the controller has an address. So how do we address these 2 controllers? Well, we address them through dip switches. So the M2000, as we can see on the top right, we can see the dip switches right in the middle on the top. So we see the red dip switches. On the C1000, they are not immediately available in the field of view. So we have to remove the cover. And once you remove the cover of the C1000, and then you're going to see the dip switches. And so it is binary addressing, and we use the first 7 switches to use for the addressing. So As we can see on the screen, each switch number has a binary value. And how it works is depending which switch you push up, you simply add the binary values all together. So, let's say I had an example where I pushed up switch number 2 and number 4. Well, switch number 2, his binary value is 2. And switch number 4, his binary value is number 8. So if I have switches number 2 and 4 up, then the address of the controller will be 2 plus 8 equals 10. So the address of that controller will be number 10. And so every possible variation of all these addresses that you could ever come up with is 127 variations. And so that's why we are limited to 127 controllers on a single network. Okay, so that about covers it for the hardware overview. Now I'm going to jump onto my software and we'll start taking a look at some of these configurations. This, and I'll open up my focus. So I'm going to log into my account, which is completely free to do. And I'm just going to create a new project. I have a little demo board beside me, so I'll call it the RTU AHU demo. And in this case, I'm going through our adapter, so it's a serial port, and I know it's COM number 10. Okay, so I'm simply going to connect here. So I'm going to open a connection through my adapter. So on the left-hand side, as usual, we have all the different menus where we can access all the different controllers. So for the constant volume rooftops or single zone rooftops, it's not in the master segment, it's in the zone segment right here. So we have zone thermostat, and here we go, and here we are, the single zone rooftop RTUS. So I'm just going to drag and drop it in. It's going to ask me for the address. So on my controller, I have switches number 3 and number 5, which are up. So if I just kind of want to remember quickly, I know that number 3 is address 4 and number 5 is 16. So 4 plus 16 is number 20. So if I put number 20 right here and hit OK, and here it pops up. Beautiful. So we can see that it's number 20 right here. And already we can see some information. So we can see what's the zone temperature, what are the set points in the space, what's the demand, is there a heating demand or a cooling demand, and what's the supply temperature. Now, I don't have an actual supply temperature sensor connected into it right now, so that's why we see NA. So if I want to configure this one, I just double click on it. Okay, so here's the default view for the single zone rooftop control. So just taking a look at the graphics a little bit. So here we've got our cooling coils, we've got our fan, we've got our heating coils, we've got our 3 temperatures, supply temperature, return temperature, outside temperature. We've got our outside damper. So here we can see what the actual position is. Here's a graphic of the filter. We've got our date and time. So remember, the M2000 has its own date and time. And right here on the bottom left, we have the space temperature with the heating set point and the cooling set point right there. So since I'm slightly below my heating set point, so it's 70.7 and I'm at 70.5, well, I can see that I have a heating demand. And you can usually tell very quickly on the visuals, is it in heating mode or in cooling mode? So in this case, if the icon is red, we know it's in heating mode. If the icon is blue, it's in cooling mode. And if the icon is green, it means it's not heating or cooling. It's simply ventilating at that point. We've had some people call us in thinking that if an icon is red, it's some kind of alarm status. So I just want to reassure everybody that it is not red because of an alarm. It's simply red because it is in heating mode. All right. Something which is included with all of our controllers is that, as you saw, when I brought the controller in and I double clicked on it, all these graphics popped up automatically. Well, that's the case for all of our controllers. So there's no graphics which you have to put together. All the graphics are already included, and the graphics will self-adapt as you make certain changes to the sequence. We can't customize the exact look of the graphics, but we tried to cover all our bases for what we typically see in the field. So looking through a few of these menus, let's say I want to configure my cooling coils right here. So I could do config, cooling, and then it brings you to a configuration menu. So here's as difficult or as complicated as it's going to get. It is configuration menu. So there's no programming, whether it's block programming or line programming. You don't have to worry about that. Everything is already done inside the controller, and we simply offer you all the different set points. So here I can choose how many stages do I have. Is it 1, 2 stages? So if I choose one stage and hit apply, every time you want to make a change to the controller, whatever change you do, let's say change it to 22, and we want to apply the change to the controller, we have to press on the apply button right there, and then it makes the change right away. And then if I go back on the home button, well, before we had 2 coils, now I only see 1. So that reflects my 1 coil. Now, you'll notice here that we do have minimum on and minimum off time. So this is to prevent any kind of short cycling. And as soon as I put more than 1 stage, well, then we also have the interstage activation delay and interstage deactivation delays, which also become available. Okay, we'll also see that right here, it says when we want to choose 3 or 4 stages of cooling. It says when 3 or 4 stages of cooling are selected, DO2 will pulse. Therefore, we need a demux-4J to transform the pulses into on-off stages. So this is touching on what I mentioned before. And it's the same kind of message. If we choose a analog cooling signal, we get another message which says that we need a PTA2. Now, we show in our hardware guide how to connect these devices. So if you're wondering how to connect it, we can access it through the hardware guide. Okay. If we take a look at the heating menu, well, here it's a little bit different. So here we can configure digital output 4, digital output 5, and analog output 1. So let's say I wanted to configure this for 2 heating stages. I could simply say digital output 4 will be a heating stage, digital output 5 will be a heating stage, and analog output 1 will be off because I'm not using it since we don't have any heating modulation right there. So right now I have configured my unit as 2 cooling stages right here and 2 heating stages. If ever you just want to access those menus a little bit quicker, you can always double click on that specific part of the graphic, and then it's going to bring you to that specific menu. In the case where maybe I don't have 2 heating stages, but I have a modulating gas valve, well, in this case, I could go into the heating and say, I don't have any heating stages at all, and I just want to use my analog output here for heating. And there we go. And that's as easy as it gets for changing it from staged heat to modulated heat. And moving on, if we take a look at the fan, so I can do config fan, or I can just double click on it, and it brings me to the same spot. So this menu is pretty easy to understand. So usually when it's occupied, we can choose in what mode it's going to be. So default, we keep in occupied, we keep the fan on. When it's unoccupied, we'll keep it in automatic mode, which we see just here, and override mode. Override mode is when someone comes after hours and they push the override button on one of the wall sensors. Well, then the unit will typically go into occupied mode for about 2 hours, or we call it override mode. And so here we get to decide, well, what is the fan going to do if someone pushes that override button? When it's in unoccupied mode and we choose it in automatic, such as we see here, well, we're only going to activate the fan if there's a heating or cooling demand which gets greater than these values right here. Obviously, these values are configurable for you. So if you want to change this from 10 to 40% on heating and maybe 50% on cooling. So this is completely up to the contractor or the installer, but I'd say most people tend to leave it at 10 and 10. Here we have the minimum fan cycle time. So once the fan does turn on, it's going to stay on for at least 15 minutes, no matter what. Okay. Now, right here at the bottom, we have a checkbox that says use digital output 5 to control an exhaust fan. So like I mentioned in the PowerPoint, we can control an exhaust fan with the M2000. So we can do it based on occupancy. Now, what if I have this output 5, which is controlling an exhaust fan, but I also have 2 heating stages, which I want to control? Well, now I might have a problem, because if I go back to the PowerPoint and I look at that M2000, well, I can see that digital output 5 heat, I was using that one for my second stage of heat. But if I'm going to use it for the exhaust fan, well, now I've lost my output for the second heating stage. Well, we have a little trick up our sleeve that what we're going to do, if I go onto the heating output, so let's say I use DO4 as my first heating stage, and you'll see that digital output 5 has been grayed out. I'm not able to change what's going on here because in the fan menu, I said I want to use DO5 for the exhaust fan. Well, I still have my analog output, which is available. And what I'm going to do, instead of leaving it in proportional mode, where it's going to be a full modulating signal, so slowly going to ramp up from 0 to 10 volts DC, I can simply change it in differential mode. So when you change the analog output in differential mode, now the output is going to act like a digital output. It'll either be 10 volts DC or 0 volts DC. So all we need to use is a DC relay, which will energize the coil once it hits 10 volts. I know there's a lot of different kinds of relays out there on the market. So, and I've seen that most of them work with our system, no problem. So all you need is a DC relay, and now we're able to configure our controller to be a 2 heat, 2 cool with exhaust fan control. So just to finish on the exhaust fan portion, so usually we'll turn on the exhaust fans based on occupancy right here. And we have something called a morning delay. So when the unit first becomes occupied, well, we might delay before we turn on the exhaust fans, because perhaps in a building, everyone, all the occupants will come in around 8 a.m. And so we might start up the unit at 6:30 a.m. or 7 a.m. So in that case, we don't need all the exhaust fans to turn on once it becomes occupied at 7 a.m. Maybe we can delay that a little bit. So here's that morning delay. Also, we're able to use a power exhaust right here. So in this case, we're going to activate the power exhaust output based on the outside damper position. Okay. All right. What else do we have? Okay, if I go on to the zone right here, what I want to point out is we do have set point limits. So if we want to lock people in within a certain range where they can't push their set point too high or too low, so we generally want to change those parameters right here in the set point limits. So we can give them as wide a range as we want, or we could give them a range that's so tight that they barely have any wiggle room at all to change their set point. So all this would be done through the software. We also have our unoccupied mode values right here, which is the nighttime setback. So when it goes into unoccupied mode, we will push our heating set point down, and we will push our cooling set point up right there. And remember before when I was talking about the override button on the wall sensors? Well, here's where we can change the default time at which the unit is going to enter override time right there. Now, here we have a default heating set point, but we don't have to worry about that too much because he's going to be reading those values from the wall module right there. If there's anything that we do want to change is maybe just the deadband. So instead of the deadband being 1.8, maybe we want to push it up or push it down depending on your application. So here is where we are going to configure that right there. So next, I'm not going to get into the pressure because we're in the constant volume. If I go into the damper right here, so I can do damper economizer. So here's a checkbox whether we want to use our economizer or not. And here's the changeover setting. So when outside temperature gets above this value, the economizer will not be activated. So for any kind of cooling, we must go through the mechanical cooling. And when the outside temperature gets below this value, now we can open up the outside air damper to provide free cooling to the building. Now, we don't have to use this function. I could simply disable the economizer, and then we will see it right here. Well, rather, we won't see it right here. So we've seen that the damper has actually disappeared, and we don't see outside damper position anymore. So if ever you have a unit that already has an economizer control on it, whether it comes pre-installed from the rooftop unit factory, or if you have a third-party device, we are able to command it simply with our cooling signal, and then we'll let the internal logic of those devices take over. However, I've seen a lot of cases where either those devices are non-existent or they're not working anymore, and at that point we would want to use our economizer controller, so we are able to do it right here. So we have a few different methods here, but I'd say the most common one, which we'll see, is we're trying to control the supply temperature based on the cooling demand. So if the cooling demand is about 15%, so it's a relatively light cooling call, then we'll target this temperature. And as the cooling call increases up to this value, well, then we're going to push our set point down right there. We've got different damper speeds, but most people tend to use 1 or 2. So what this is, it's not actually how quick does the damper open and close, it's how often does the damper reposition itself. So at speed 1, it repositions itself every minute, so every 60 seconds. And then every subsequent speed, we divide that by 2. So speed 1 is 60 seconds, speed 2 is 30 seconds, speed 3 is every 15 seconds, speed 4 is every 8, and speed 5 is every 4 seconds. Now, most of the time, we just need speed 1 or speed 2, so the outside damper readjusts about every minute or every 30 seconds or so. Why did we put such short intervals right here? We put it more for a troubleshooting purpose when people are in front of their units and they want to test things out and they don't want to wait a minute just to see if it's going to change. So just know that we generally keep it at 1 or 2. Here we have our minimum damper position. So we can say, I want to keep my minimum damper open at least 10% when it's occupied. When it's unoccupied, the minimum damper position goes down to 0. And here we have the morning ventilation period, where essentially the minimum damper position is going to remain 0 for the first 90 minutes. So for the first 90 minutes of occupancy. we would see this in a situation where, let's say it's winter time, and we want the unit to start up and start heating up the space. Well, we don't need to open up the damper at 10 or 15%, because at that point we're letting in very cold air and we have to heat it up. So what we'll say is maybe for the first 90 minutes of the day, we are going to hold off on opening the damper to the minimal opening. But this is a checkbox, so you can enable this or disable it. And then we have the mechanical cooling with economizer. So if you check the box, once it goes below 55 Fahrenheit right here, the economizer will turn on as a first stage, and then the mechanical cooling can also turn on as a second stage. And as we'll see, there's an alternate set point for cooling stage 1 and an alternate differential. If you uncheck the box, then what that means is when the outside air gets below 55 or whatever value we put here, then the mechanical cooling will never turn on, and we are solely going to use the outside air for cooling. Okay. If we want to use the CO2, well, here we have to activate it right here. And then when I go back, I will see my CO2 sensor right here. And how this is going to play, he's basically going to play on the outside damper position as well. So here we put our set point with the proportional value. We do have a limit. So let's say I put my set point at 1,000 and my proportional is at 200 right here. And in the space, I'm reading 1,300 ppm. So now I'm at a 100% CO2 call. Well, we're going to open up the outside air damper. However, we can limit what the outside damper position is solely based for a CO2 call. So perhaps we don't want to let the economizer damper open all the way simply for CO2. So we can limit what the maximum damper opening is for CO2 purposes. And you don't have to worry about tripping any low limits or anything like that, especially in wintertime, because we're also monitoring what the supply temperature is. So if ever the supply temperature starts dipping below this value, well, then we start closing the outside air damper because we don't want to compromise the HVAC system simply because CO2 is a little bit high. So if ever the temperature starts dipping below this, we start closing the outside air damper. If we want to do the dehumidification, so here we'll have it like this, and then here we have the menu to config the dehumidification sequence, where typically we will turn on the compressor stages, and if we have a modulating heating output, we can also reheat the air up to a specific temperature so that we're not overcooling the space. So we're cooling the air so that the coils will withdraw all the moisture from the air, and then we reheat the air so that we don't overcool the space. Okay. We do have built-in limits as well in these controllers. So it's not going to heat or cool nonstop. We are always looking at temperature in the return, in the supply, and the outside air temperature as well. So let's say looking at the supply temperature, here it says stop cooling stages in succession when lower than 48. So if your supply gets colder than 48 degrees, we will disable the cooling stages. Likewise, on the heating side, if the supply gets higher than 122 or whatever value you choose to put in, then we can disable the heat. If ever we have a modulating heat, so maybe it's natural gas or something like that, we can limit also what the discharge temperature is. So let's say that the unit goes into full heating and our output goes to 10 volts, so it's at 100%, but then the supply air gets very, very hot. Well, we can limit what the discharge temperature is when it does enter that full heating mode. Likewise, we can disable the heating and cooling based on outside temperature as well. I've seen some cases where the unit would overcool the space and then the unit would start heating in the middle of summertime. So the people would get heating bills in summertime simply because they chose to push up this value to 90 or 100 degrees for outside air temperature when that probably wasn't the best decision to make. We can also restart the fan. If ever outside temperature gets really cold or really hot, as in some climates, either in wintertime or summertime, we can also make sure that the fan starts up again to avoid it from any damage from it not moving in those extreme temperatures. We would just rather the fan continue to be activated. Okay. As we can see with all our controllers, we do have a template system. So once you've created a controller which you like particularly, or let's say that you have multiple units of the same one, you could save it as a template, and then you can use it over and over again for multiple units across multiple projects. Okay. One of the things which I absolutely wanted to show you guys is how do we know when the unit is going to start heating or cooling? So all of this is based off of the demand coming from the space. So as we can see, this unit has a 86% heating demand right there. So let's say I were to take this the other way, and let's say I take my wall sensor and I'm going to push it down. Okay, so I just changed the setting on the wall sensor. So as you can see, my heating cooling set points have gone down. And now I can see that the unit has a negative demand. So that means it's a cooling demand right now. So how do I know when when my cooling stage, when is it going to turn on? So I can double click here. So here we have the set point and differential. So I'll just put this back to the default value. So if you just hover over the word differential, we have a little pop-up, and we have this set up a little bit everywhere in our software if there's a field which you're not sure how to use. So in this case, when does the cooling stage turns on? As we can see, there's a set point, and the differential is like a bracket which is centered on the set point. So we have half the differential on one side and half on the other. So just looking at this, I can see that the first cooling stage will turn on once we reach the set point plus half my differential. So once I reach 35 plus 10, so at a 45% cooling demand, that's when my first cooling stage is going to turn on. Now, if I just go back here, hold on, I have the dehumidification, which I'll just disable right here. Okay, actually, my space actually just went up. Okay. Sorry about that. Okay, so now we'll see that it's going to go back into cooling mode. Okay. So we see that the demand is at 36%. But I know that my first cooling stage, he turns on at 35 plus 10. So once this demand reaches 45%, at that point, I will see my first cooling stage turn on. So if I want to, if I just want to change this and maybe simulate it, let's say I bring my set point down to 15%. So now my activation is 15 plus 10. So at a 25% cooling demand, I should see my first cooling stage turn on. Oh, see here, I'm actually at 23. Oh, there we go. So I just hit 31. And so now usually I would see my unit go into cooling mode. We do have a little delay. So when your unit is in heating mode and then it switches into cooling mode, there is a little delay. So I know that my unit was heating before, and now when I did the switch, well, I think it's like a 5-minute delay. So, and that's kind of what we're experiencing right here. So in a matter of minutes, we would see the first cooling stage turn on. And so here's how you are able to configure your stages differently, whether you want one stage to turn on earlier. So if you want it to turn on earlier, we'll play with the set point. And if we want to play with how long does it stay on, because maybe some people will say, once it turns on, I don't feel that it stays on long enough, or we start satisfying the space, but maybe not enough. Well, maybe we want to widen our differential. If there's something that you don't want to do, is give it a very short differential. Because if you give it, let's say, an 8% differential, well, then it's 4% on one side and 4% on the other. So we'll see that the unit is going to turn its cooling stages on and off rather rapidly. So we want to avoid this short cycling. So if you're able to put a larger differential value, that is what we highly recommend. Okay. In terms of the scheduling, so we can see that this controller has its own time clock in it. If whenever you get it, sometimes it has somewhat of a strange date and time, but that's normal. And so just hit edit, and it's going to look at your computer time versus what's in the device. So as you can see, I'm a little bit off because my demo board has been off for a few days now. So I can just hit copy right here, and then it's going to synchronize it right there. We do have the daylight savings time as well, so that we don't get caught on those days where we change the hour. All right. So in terms of the scheduling, I can just go on network schedule right here. Oh, and here we can see that the timing delay expired for the switchover from heating to cooling. So I can see that my cooling stage turned on. So in terms of the scheduling, I can just do network schedule. And then here's all of the, so here's your weekly schedule. So I could say on Monday, you become occupied at 6 a.m. And we have 4 on-off periods on any given day. So I could say go on, let's say I'll just choose off here. I want to go off at 8 p.m. And let's say it's a regular Monday to Friday type business. Well, I can just choose my Monday and I can paste it to the other days of the week right there. So if I leave it like this, well, on the weekends, it's going to remain unoccupied because he looks for any kind of change. So on Friday, it'll become unoccupied. On Saturday, there's no change. Sunday, there's no change. And then on Monday, oh, here we have a on point again. So at that point, it'll become occupied. So with this kind of setting, Saturday and Sunday will remain unoccupied. You don't have to add another off time in that case. Here we also have a holiday column as well. So which day of the year is a holiday? Well, that's, once again, it's embedded. Just go into the calendar, and then you choose which days of the year is a holiday right there. And so on those specific days which you choose in this menu, well, then we're going to apply the schedule of this one right there. Now, we can get into more scheduling options with our network controller, because the network controller, he can manage up to 16 schedules, and he can send different schedules to different controllers. So if ever you have a larger network system, and let's say you've got multiple rooftops, let's say you've got 5, 10, or 15 units, and they're all following the general schedule, well, at that point, we'd probably recommend using the network controller, and we'll do the schedules in that controller, and then that controller will dispatch either one schedule to all the devices, or if we have multiple schedules that we want to spread out through the different devices, we can. Okay. We're at about 1:55, so that covers a lot of what I wanted to show you guys. Sophie, do we have any questions?
I don't have any on my side, and I don't see anyone asking questions in the chat, so we may give you a few minutes if you have any questions, everyone. You can type them in the chat right now and we'll get to them.
Okay, so while we wait for those few minutes, I'm just going to show just a few more things. If I just close this one, actually, one of the new things that which we've added on is mode set. And so here, this is something which was asked from a lot of our customers is, can we force the system into either heating only or cooling only, or we want to force it off? So you can access this through mode set. So if we choose heat, then the unit will only enter heating mode if it wants to, but it will never cool. So it'll never enter cooling mode. If we choose cool, well then it's the other way around. If the space wants cooling, it will. But if the space wants heating, then it's not going to do anything. And off, well, in this case, both heating and cooling will be disabled, and only the fan is going to run. And then here we can just automatically override the fan to do something specific. Talking about overrides, if you right-click on any element, you can override it right here from this menu. So I could say, okay, I want to turn off my fan, let's say, and then I'm just going to disable the fan right there. It still says proof yes because I have a little jumper. If I just remove it, and then we'll see it. There we go. So here we'll see the proof no. There we go. So simply by right-clicking on an element, you can override it from here where there's the heating, the cooling, and the outside air damper. If I just go back to normal here, if I hit config edit display, you can choose to not show certain sensors right here. So if I want to show, let's say I don't have a return temperature sensor and I don't have a supply sensor, for example, I'll just go here and then so we can see that the supply and return have disappeared. Remember on this controller, I said there's a multi-purpose input. Well, here's where you choose what you want it to be. So we can choose a mixed air sensor, and then here we'll see it pop up. If we want the dry contact for the clogged filter, so we'll see it here. So it'll either say filter okay or filter dirty. We can use it for the schedule override. So that's if we just want any external switch to be able to force the unit into occupied mode, we can do it. Or here's that auxiliary temperature input, which I mentioned before. We can use it for any temperature that we just want to monitor, which doesn't really affect anything. And so let's say I'll call it room number 1, for example. And then we'll just see it right here. So we'll just display it at the top right, right here. Okay, that's not going to get into that today. In terms of calibration, here we generally don't have to enter it. It's just in case the wall, any of the temperature sensors or the transmitters, if ever the value which it's reading at the controller is off, maybe the supply sensor is reading 70 degrees and you're reading with another thermometer that is actually 60 degrees. And there's always this 10-degree offset. Well, we can just manually offset these temperatures right here. I've also seen people use this menu just for troubleshooting if they just want to simulate what's going to happen if there's a jump in temperature, or if there's a drop in the temperature as well, just to see how is the unit going to react. So we're able to do some simulations with that as well using this calibration menu. And so just one of the last things I want to share. So here's a M2000. If I just disconnect and I'll bring in a C1000 one, I don't have one on my board. So I'm just going to put one and it'll be a C1000. So it looks virtually the same, except for it's just a little bit more limited. We call it the basic single zone rooftop. So if I go onto the cooling, this is very much the same. If I go on the heating, well, look, we don't have that digital output 5 like we had before. So here's just digital output 4 and the analog output right here, as well as if I go into this menu. So as we can see, we don't have all the same options, but sometimes when it's just like a one heat, one cool unit, no economizer, it's just a basic setup. Well, in that case, the C1000 will do just fine. Okay, all right, so that basically wraps up what I wanted to show you guys. Sophie, have you had any questions come in, or?
No, we still have anything, so I guess you were very clear.
Okay. All right. Well, I'd like to thank everybody for attending the webinar. If ever you have any questions, you can reach me or anybody on the ProLon team. We would be glad to help you out in any way we can.